Claire here for Claire Maths. Today we're doing the Higher Maths 2024 Paper 1 Essential Skills paper, which you can find on my website as usual, link in the description. Let's get started straight away. Number 1 says triangle TUV has these vertices. Find the equation of a median through T. So a median is the line that goes from T and cuts the opposite line in half. That's not a very good drawn line, but you can get the idea. So it's cutting that in half. So I need the midpoint of UV, mid of UV. So very quickly here, 4 plus 6, you add them up and divide by 2. And then 7 plus 1, you add up as well and divide by 2. So we get an answer of 10 over 2 is 5 and 8 over 2 is 4. So there's my midpoint. Let's just call that M. And now it's straight line stuff. We can do a gradient. So the gradient of MT, y2 minus y1, so that's 4 minus 3, over x2 minus x1, which is 5 minus minus 2. That gives me 1 on the top and 7 on the bottom. So now I've already denoted AB for my midpoint, so I'm just going to do y minus b equals m x minus a. And most of the time you would times by 7 to get rid of that. So I've got 7 bracket y minus 4 is 1 bracket x minus 5. So that's 7y, 7 4s are 28, equals x minus 5. A few ways you can leave this, but I'll just leave it equal to 0. So I've got 7y, I take the x across to get minus x, and then I take the minus 5, so it's plus 5, so that gives me minus 23, and that equals 0. And we're done there. Now you can also leave it as 7y minus x equals 23, or y equals, and just divide through by 7, but I wouldn't bother in this case. Question 2, a function f of x is defined on R, the real numbers, by f of x is 4x minus 5 over 2. Find the inverse function. There's a few ways to do this, but I'm going to show you the most common way and the pitfalls to avoid. What I do is I call this y equals 4x minus 5 over 2, and you're going to make x the subject. So you're going to rearrange. So 2y times them through by 2 is 4x minus 5. Adding 5 to both sides, you get 2y plus 5 is 4x. And then divide by 4 then, so 2y plus 5 over 4 must equal x. Now at this stage you need to be very careful. You do not now write y equals 2x plus 5 over 4. That's a big no-no. If you do that, you've got 2 y's here and here for the same equation, which are not the same. So therefore you'll get a contradiction and an SQA will take a mark off you. So what you do instead is, you just get to this point, tick, and immediately write down the inverse function of x equals 2 and y becomes x plus 5 over 4, and you'll get your full marks. Okay, SQA Higher Maths 2024 Paper 1. This is the Essential Skills paper. F of x equals 4x plus 1 cubed. Find f dash minus 1. Dash is differentiation, and this is the chain rule. So let's work on this. F dash x. So imagine that 4x plus 1 is just like my big X. 3 comes down to the front. That 4x plus 1 stays the same, and I take away 1 for the power as normal. But then I need to remember to times by the derivative of the bracket. So the bracket's 4x plus 1. Differentiate 4x, you get 4. So that, tidying that up, 3 4s is 12, 4x plus 1 squared. And now it says f dash minus 1, so I put in minus 1. So minus 1 for x gives me 12. 4 times minus 1 plus 1 all squared. That's 12. Minus 4 plus 1 is minus 3 squared. That's 12 times 9. Well, 9 2s is 18. 9 1s is 9. Plus 1 is 10. That's 108. And we're done there. Question 4. Evaluate a third log 8 125 plus 7 log base 8 2 minus a half plus log 8 100. So this is using the rules of logs. So let's start with the first one. That log base 8, I can take the 125 and the third can jump up as a power. Plus, same with the second one, log base 8, 2 and the 7 can jump up as a power. Minus log base 8, 100 and the half can jump up as a power. So let's work out these powers. Remember, a power of a third is the cube root. So I want the cube root of 125, well 5 times 5 times 5, so that's 5. And then a half power means the square root of 100, which is 10. So we've got log base 8, and that gave us 5, plus log base 8, 2 to the power 7, 2 to the 4, 8, 16, 32, 64, 128. Should be able to do that. Minus log base 8 of 10 tens is 100. So that gives me Rules of logs, adding means I can times, 5 times 128, take away means I divide over 10. Now, there's lots of ways you could work this out, but I'll use the most efficient method. Log base 8, 5 over 10 is a half. So I can simplify that by doing 1 over 2. So that gives me 128 over 2. That's log base 8 of 64. And 8 eighths are 64, so that's 2, because 8 squared is 64. SQA Higher Maths 2024 Paper 1 Essential Skills Question 5. A line makes an angle of pi over 6 with the x-axis is shown. It passes through 4, 0. Find the equation of a line. So we should all know that gradient equals tan theta, but that's with the positive direction of the x-axis, not just any direction, so that's the wrong side. So I need to go over this side. So pi over 6, you can think in terms of radians or you can think in terms of degrees. I think it's sometimes easy to think in terms of degrees. 180 divided by 6, 6 into 18 is 3, so that gives you 30. So 180 minus 30 for the straight line is 150 degrees on this side. So our gradient equals the tan of 150. Now that is a related angle. If I draw my little cast diagram, 150 would be in here, and to get that it's 180 minus. So 180 minus something is 30 degrees. So if I work out the tan of 30, which is an exact value, there's a little triangle to help. I've got 60 and 30 down here, 2 and 1 here in root 3. Tan of 30 is 1 over root 3. But that means that my gradient is not 1 over root 3. Be very careful here, because 30 is not the angle I've actually got, it's 150, which is here. And 150, when for tan, is negative here, because we're in the S quadrant. So we need to write minus 1 over root 3. So be careful. And now we can do it. Our point is along 4, 0. There's my A and B, if you're going to do it that way. Y minus B, y minus nothing is nothing, equals M minus 1 over root 3, x minus 4. Expanding the brackets, we get y equals minus 1 over root 3x, and a minus times a minus is a plus, so plus 4 over root 3, and we're done there. Question 6, find the equation of a tangent to the curve y equals 2x squared plus 8 over x at the point x equals 2. So I need to get that ready to differentiate for equation of a tangent. I need the gradient, which is the derivative, and I need a point. So I'm going to do derivative first. So y equals 2x squared plus 8x to the minus 1. So the gradient is the y by dx, which is 2 2's are 4x. And then take 1 down, so minus 8x, and then minus 2. But I'm going to have to be able to actually sub something in. So I'm going to write that as 4x minus 8 over x squared. So for x equals 2, our gradient equals 4 times 2 minus 8 over 2 squared. 4 2's are 8, minus 8 over 2 2's are 4. 8 minus 2, which is 6. So now we need our point. So when x equals 2, y equals 2 times 2 squared plus 8 over 2. That gives me 8 plus 8 over 2 is 4, which is 12. So our point is 2, 12, and our gradient is 6. So now we just do y minus 12 is 6x minus 2. So y minus 12 equals 6x minus 12. If we take the 12 over, that becomes plus 12, so that eliminates with a minus 12. So y is just 6x, and we're done there. The line x equals 3y plus 5 intersects the circle x squared plus y squared plus 10x minus 10y minus 75 at 0 at P and Q. Find the coordinates of P and Q. So this is just subbing in. Usually you're told y, but this time x. You just sub in x for x in the equation. So x squared becomes 3y plus 5 squared plus y squared plus 10, 3y plus 5 minus 10, y minus 75 equals 0. So I expand the brackets. Now double brackets, if we square the first term, you get 9y squared. Times them together, 3 5s is 15, and doubling it to get 30y. Then 5 5s is 25. Or do it any way you want. Plus y squared, plus 30y, plus 50, minus 10y, minus 75 equals 0. Collect the terms. The y squared terms, I've got 10 of them. The y, I've got 30 and 60. Minus 10 is 50. in the numbers, I've got 25, 75 minus 75 is 0, so it just equals 0. Usually you get a number on the end there, but sometimes if it goes to 0, it's just an easier question. So you usually get a quadratic of some description. This is an easy one. Common factor, 10y. That gives me y plus 5. So that means that 10y equals 0, so y equals 0, or y plus 5 equals 0, so y equals minus 5. But we need points, so we need to use our x. X equals 3y plus 5. So at y equals 0, x equals 5, and at y equals minus 5, x equals 3 times minus 5 plus 5. Well, that's minus 15 plus 5. That's minus 10. So our points, remember points are x, y. For the first one, we've got 5, 0. And for the other one, we've got minus 10, minus 5. So what points are which? We're looking at this. The negative one's P on the x-axis. So that's P and that's Q. And we're done there. Question 8, show that x plus 1 is a factor of this and then factorise fully. So part A, quite often people use synthetic division, so I will as well. So you put x plus 1, make sure you put minus 1 in the root outside. 2x cubed minus 9x squared minus 6x plus 5. Make sure they're going down in powers, if not add a 0 in somewhere. Okay, 2. 2 times minus 1 is minus 2. Then you get minus 11 when you add, and then 11. 11 minus 6 is 5. Then you get minus 5 when you times. Minus 5 and 5 is 0. So therefore, I say a little statement. Remainder equals 0. So x plus 1 is a factor. Part B, hence or otherwise factorise fully. So I've got x plus 1 already, and now I've got 2x squared minus 11x plus 5. So that's x plus 1, and then hopefully that's double brackets. Now I've got 2x and x. I can only have 5 and 1, so it's either going to be 10 and 1 make 11, or the other way around, but I know it's 11 I need. So it's 5 and 1. So I get 2x minus 5 minus 1, because I want minus 10 minus 11. And that's it, we're done there. 24, question 9 for the essential skills. This graph shows a cubic curve with stationary points minus 4, 5 and 0, minus 1. Sketch a graph of y equals minus f of 2x plus 3. Okay, be very careful with this one. So let's start on this one by drawing out a diagram. Nice and neat. Although in the exam you'll actually get a diagram grid to draw on. So what's happening? I've got a minus, so I need to go up. I need to flip it in the reflection in the x-axis. So I need to flip it upside down, in other words. And then inside the bracket means this is acting on x, so I'm going to do something to x. Now 2x, if it's inside, here's a little tip for you. You do the opposite of what it says. So I'm not going to times, I'm going to divide by 2. If it says a half x, I would times by 2. If it said plus, I move to the left. If it says minus, I move to the right. Then the last number, plus 3, means I'm going to go up by 3. So looking at my points, minus 4, 5 is what I've got to start with. So first thing I'm going to do is act on that negative. So if I act on the negative part, and then that becomes, doing the negative part, minus 4, and it becomes minus 5. And now, if I act on the plus 3 part, I've got minus 4 and minus 5 becomes minus 2. But then the 2x bit means a half the x coordinate, minus 2, minus 2. So that's my first coordinate. And then my next coordinate is 0, minus 2. So if that gets flipped upside down, the y part becomes 0, 2. And then I need to add 3. So 0, 5. But then I need to half the x coordinate, half of 0 is 0, so it's still 0, 5. So there's my new point, so I can just put them in. So I've got minus 2 somewhere. Just label it minus 2. And I've got 0, 5 up here, so just label that 5. And then it's went upside down, so instead of it going up, it goes down away. So I'll just get something that looks like that. And we're done there. On a separate diagram, sketch a possible graph of y equals f dash x. So part B, to sketch f dash x, here's how I always think of this. Think of this y-axis as actually your f dash x, basically, and that's your x. And when you're thinking about the derivative, so draw myself a little nature table. My turning points are -2, 4, sorry, and then 0. And then I'm going to look at the y by the x. So on the turning points, the derivative is 0. If I look here, I just check, it's going positive, negative, positive. So I just put that in, positive, negative, positive. But if I'm now drawing this on a new grid, and effectively the y-axis is f dash x, then f dash x is 0 and 0. So I'm on the x-axis. So I can just put them on as roots straight away, -4 and at 0, 1 and 0. Now let's look at what we're going to have to draw before and after. That's my x-axis. That's a bit messy, but there you go. Before -4, the derivative is positive. So I need to be in the positive part. So I need to be up here. Between the derivative is negative. So f dash x is negative. So I'm down there. I just put a little dot. And then after 0, I'm positive again. So I'm up here. So I put a little dot. So you can kind of then see your shape. You see it's some sort of curve because it has to go down, has to turn at some point and come back up. So you just kind of draw that in. And if you've put any little random dots that you're not using, you can go back with your grubber and take them out, but you get a graph that looks like that. Also to note, 2 turning points like this on a graph is a cubic graph, and a cubic should turn into that. But you can also just do it from that, and you'll be there. Fine. Question 10. The points A, B, C are collinear. A has these coordinates, B has that coordinates, and B divides AC in the ratio of 3:1. Determine the coordinates of C. I always draw a little diagram for this to see what's happening. So if I draw this diagram here like a A, and I've got C on the end, and B divides it in the ratio of 3:1, I've got 3 here and 1 here. So 1 lot of AB would equal 3 lots of BC. So I can just write that down. AB equals 3BC. Now, I know AB is B minus A, and that equals 3C minus B. So expanding that, I've got B minus A equals 3C minus 3B. And I want to know what C is. So I'm going to just rearrange this. So I've got B minus A plus 3B equals 3C. That's 4B minus A equals 3C. So dividing by 3, the vector C must be 4B minus A over 3. And we get to there. So then we can just sub in. B is 713. So I've got 4 lots of 713 minus A, which is -27 minus 3. And then we're going to divide that whole thing by 3, which means to divide each number by 3. 28, 4 threes are 12, minus 2, 7 minus 3 equals, and that's all divided by 3, remember, 30, 4 minus 7 is minus 3, 12 minus 3 is 15. All of them need to be divided by 3. It gives me 30 divided by 3 is 10, minus 3 divided by 3 is minus 1, 15 divided by 3 is 5, or C equals 10 minus 1, 5. And we're done there. Question 11, integrate 8 sine 2x minus pi over 6 dx. Okay, so integrating sine or cos, go to the start of the exam paper. So copying over that standard table of integrals, you'll see that if you integrate sine ax, you get minus 1 over a cos ax plus c, and for cos it goes 1 over a sine ax plus c. So the one we've got is sine, but this is just a guide, it's actually just a chain rule. It's saying that if I've got sine ax, sine goes to minus cos, and then I divide by the derivative of this bit, which is a. But at higher maths, you're often given ones like this. So you just do exactly the same. You keep the 8 in and you keep this in. So in other words, using my table is very easy. It's minus 8 cos, I've got 2x minus pi over 6 plus c, and then it says divide by a. Well, that's my a there, so divide by 2. I've just differentiated 2x minus pi over 6 effectively, but not had to think about it too much. So now just tidying that up, 8 divided by 2 is 4, so you get minus 4 cos 2x minus pi over 6 plus c, and we're done there. SQA Higher Maths 2024 Paper 1 Question 12 for this Essential Skills paper. Solve the equation sin 2x minus 3 cos x equals 0, and then hence solve the next one. So let's look at A. So start of the exam paper, sin 2x is 2 sin x cos x. And then I've got minus 3 cos x equals 0. And we're also in radians here, so make sure your answer's in radians. So this here, I've got a common factor of cos x. So I can just take cos x straight out. I've got 2 sin x left. And then I've got minus 3 is 0. So that means that cos x equals 0, or this whole equation equals 0. So I just solve them separately. So cos x equals 0, 2 sin x minus 3 is 0, so sin x is 3 over 2. So cos x equals 0, you can just use your graph. There's the cos graph, 1 minus 1, and it goes 0, 90, which is pi over 2, 180, which is pi, then 3 pi over 2, and then for the last bit, 2 pi. So the one where it's 0 is here and here. So we can just immediately say that x equals pi over 2 and 3 pi over 2 for this one. For the other side, we've got sin x equals 3 over 2. Now, you might be thinking, wait a minute, that's not an exact value. Again, looking at our graphs. Sine graph goes to 1 and minus 1. 3 over 2 is outside that, so there's no solutions. So I could just write no solutions. So we're done there, pi over 2 and 3 pi over 2. Part B says, hence solve sin 4x minus 3 cos 2x. We'll just check to see the difference between this and this. It's exactly the same except the angle's doubled. So if the angle has doubled, that means that straight away the answers I got for part B, I could just skip ahead and say, well, cos not x but 2x would equal 0, and sin not x but 2x would equal 3 over 2. Now in this case, we're still going in the same limits, which is between 0 and 2 pi. So I need all the answers. So that means that, going back to my answers, 2x would equal pi over 2, 2x would equal 3 pi over 2, and again for this one there would be no solutions. So what does that mean if 2x is pi over 2? Well, I can work out x, but then there must be more answers because 2x goes 1, 2 graphs up to 2 pi. So to get your extras, I usually just add an extra 2 pi here and divide. Or you can divide first and then note you add pi, not 2 pi. So if I add 2 pi onto this, adding 2 pi, well 2 pi, outside here, I'm over 2. So that's 4 pi over 2. So I'm just thinking about adding 4 pi over 2. So 4 pi plus 1 pi is 5 pi over 2. And 4 pi plus 3 pi is 7 pi over 2. So now I can just get my x by dividing by 2, because I've got 2x. So I've got pi over 2 becomes pi over 4. 5 pi over 2 becomes 5 pi over 4. 3 pi over 2 becomes 3 pi over 4. 7 pi over 2 becomes 7 pi over 4. And we're done there. Question 13. The diagram shows two right angled triangles with beta and theta marked. Determine if sine beta and sine theta. So we've got two triangles. So we need to do Pythagoras to get our sides. So we've got 7 squared minus 3 squared. That's 49 minus 9, which is 40. So the height is root 40. Now it's probably best to simplify such to make your life easier later. So root 40 is root 4 root 10. So that's 2 root 10. So I get 2 root 10 here. And now we can do the same to get the hypotenuse. We've got 2 root 10 squared plus 2 squared. Well, that's 2 2s are 4, root 10 times root 10 is 10, plus 2 2s are 4, so that's 44. So we get the square root of 44, which again we can simplify, root 4, root 11, 2 root 11. So we get 2 root 11 here. And now we can actually work out sine beta and sine theta. Sine beta is opposite over hypotenuse, 2 root 10 over 7. Now, if you hadn't simplified in advance, you would have got root 40 over 7 and had to simplify now. And then sine theta for part 2 is 2 root 10 opposite over 2 root 11. So the 2's cancel to give you root 10 over root 11. Or, if you prefer, 1 square root with 10 and 11 in it. Part B, show that the exact value of sine beta plus theta equals that. So sine beta plus theta. Using sine A plus B at the start, that of the exam paper, that's like your A and B. You get sine A cos B, that's theta. Sine A cos B plus cos A sine B, sine theta. So you need to substitute in. Sine beta is 2 root 10 over 7. Cos theta is 2 over 2 root 11. And then cos beta is going to be 3 over 7. And sine theta we know already is root 10 over root 11. So let's just tidy this up a bit. These 2's can cancel to get 2 root 10 over 7 root 11 plus 3 root 10 over 7 root 11. 2 plus 3 is 5 root 10 over 7 root 11. But it's got not any roots in the bottom, so we're rationalising the denominator. So times by root 11 over root 11. That gives me 5 root 10 root 11 over 7 times 11 is 77. 10 times 11 is 110. So 5 root 110 over 77. And that's exactly what we have got. So we're done there. This has been Clever Maths today. We went through the Higher Maths 2024 Paper 1 Essential Skills, courtesy of Mr. Rennie. So thank you very much. Hope you found that useful. If you did, give it a like and a subscribe and a thumbs up. Good luck with your exams. Take care, stay safe, and goodbye.